Again, welcome to this session. Um, Hi everyone, welcome to this session. Again, we will be continuing our look into the Python programming. Last time, in the last lecture, we introduced the Python programming. Today, I will continue. In my the topics that I will be talking about, I mentioned one thing which I did not cover during last time. So I will plan to cover that plus some more topics for today. So last time I talked about the scope of variables in Python. The scope is very similar to what we have for Tickle. So I just wanted to just give you an example. So first of all, the scope of a variable is limited to the extent of a function. So if you are using a particular variable, that variable does not go outside the function. Once you exit out the function, that variable is gone pretty much. And the variable outside the function are not also taken into the function. So if you are changing any variable which is declared outside the function within the function, the Python creates a brand new variable for that, even though it's the same name, and it just overloads the name, and then it assigns the value that you are assigning. And once you leave the scope of the function, that particular variable is gone, and it uses the global variable once again. So if you try to change anything within the function and then try to print out outside, you will not see any changes. It will just be the same as before. So here is one quick example. Okay, I'm going to pause it for a minute. Okay, is limited to the extent of the function. Once you change the variables, essentially, like so any variables outside the function cannot be changed within the function. So Python usually assigns a new variable for the same name and overloads that name, and then uses that within the scope. And then once you go out, again you don't see those changes. And the same thing, so if you want to have a variable defined outside and then you want to use it within the function, you need to declare that as with this global keyword, which is shown here essentially. So it's the global keyword. So here is one example. This section is actually like a Python code. Let's review this one. So here I am declaring a global variable. It's called global var, and then it's assigned to a string. This is global. Now I am defining my function where I am defining a local var called, and we basically assign this is local to that local var, and then global var I am changing from this is global to this is local. So if I print within the function, it will be still the same. The global var will be same as this is local, and the local var is also the same. So that is when I execute this. Now if I print outside the global var, can you tell me like what it will print? It's still going to print this value as if it never got changed by my function. This is again because when you define it here, this global var is a different global var. It actually creates this variable, assigns the local, this is local, and then it prints out this. But once you go out, it uses this. So in order for us to change the global var within the function, we need to declare here like global and then global var. So this basically, like this statement, enables Python to actually get through this this issue and then actually change that to this is local and that is visible outside the function. So now when you print this one, instead of this is global, it will print this is local. So that explains the scope of variables or the variable scope. So today we will be continuing our discussions. So just a recap, in the first lecture we saw several topics basically. I just wanted to just run through several of them. I hope you remember all these things. We started with like some basic stuff, how to run Python programs. We talked about variables. We talked about how to print, and then what are the operators in Python. Some of the banned keywords also like that we talked about, and then what are the rules for having a keyword. Then we talked about how can we input a variable into the in Python or into the program, and then how to write comments, and then now today we saw the scope. Okay, so I hope those things are very clear for you. Now let's go to today's lecture. Basically, today we are going to talk about the conditionals, basically true or false booleans. True or false booleans, comparison and logical operators, and then we are also like going to look at some of these if, elif, else statements. Again, remember Python is a shorthand programming language. We want to minimize and get the most effective things in Python. So here the main thing is like the type is what is called the main thing basically, and type boolean for boolean, and then we say like type true, that's of type boolean. It doesn't matter, like I mean if you specify the lowercase t here, that's not defined, so essentially like that just results in an error. So the booleans are defined as uppercase T R U E and uppercase F A L S E. So make sure that you remember the case and use that. And if you specify something like this, 2 plus 2 equals 5, this is a conditional checking basically whether this is the same, and then the result is a false. So the true or false are of type boolean, and the capitalization is required for booleans. So just remember that. A boolean expression is an expression which can be evaluated into a true or false. The expression evaluates to false if it is it's a numerical value of 0. Essentially, like I mean, there are different ones. One is the constant false, the object none, an empty sequence or a collection, or the numerical item of value 0. Think of this basically like I mean, this is the primary one. You have also the constant false that we saw earlier. The boolean expression evaluates to false, then also it returns a false. The object is none, it again returns a false. It has an empty sequence or a collection, it returns a false. And then finally any numerical value of 0 is also like returned as a false. And everything else other than these 4 conditions, it's true for the boolean expression. So let's look at some of the comparison operators. So this one we saw in the first example, that is equal. That's actually it is a comparison to find out whether two things are equal. And then the not equal to is again it's a easy one. It checks if the two value operands are equal or not, and if the values are not equal, then the condition becomes true. So in other words, this one is evaluates to A equal B, you can say basically, and then this basically like whether it checks whether it is true or not, if they are equal or not. Here it's basically like A not equal to B, and if that becomes true, then the thing is true. And then you have a greater than, and you have less than basically, and greater than or equal to is another operator, and less than or equal to is another one. Then we also have the similar kind of operator that we saw in Tickle or even in Perl, which is like a board operator. This essentially checks if the value of two operands are equal or not. If the values are not equal, then the condition becomes true. So in other words, this is similar to the not equal to kind of thing. And then we also have something is the two references refer to the same object. This one we will cover in chapter 6. So wait for a couple of more lectures, and then we will go through that basically. This is like one level of indirection when we talk about references. Basically, the address is the same even though the values may differ. So that's another thing that we can find out. And in Python, actually, one thing that you can do is you can actually chain these comparisons. So you can define like the multiple inequalities, multiple equalities, multiple comparisons in the same line. Again, this goes to that shorthand notation that we talked about. So here, a simple thing basically, 0 less than or equal to A less than or equal to 99, and if A is 42, this expression will return true. But if A is say minus 10, this evaluates to false, even though like this side may be true. And if it is A is 100, then also it returns false because this will evaluate true, but this side is going to be false. So you can actually specify these shortcuts. This actually saves a lot of time and a lot of code. Now let's look at some other operators like logical operators. Logical operators are and or not essentially. So the and or not is essentially like through the real typing the numbers, typing the actual words themselves out. So we can specify say like 2 plus 2 equal 5 or 1 plus 1 equal 2. this will return true because this side is true, and essentially, like, I mean, this may be false, but false or true is actually true. If you say and now false and true, that is actually false. Then you can also specify not of this, which means basically like this is now true, and then this, and that becomes true as well. So one thing you note that actually we don't use the ampersand or bar or this bang as in C. So we don't do the C level stuff for using the logical operators. They are explicitly specified in the fullest form. So even though we said basically we won't specify this double ampersands and all these things, there will be like single ones that are used, which are mostly used for the bitwise operators. So we will talk about that in a little later. Now we go to the conditional ones, if then else. So here just one example called if else dot py. So you can think of you can see this code actually, which is 1 plus 1 equal 2, then print that, and then print I always thought so, and else print my understanding of the math is must be faulty. And a simple one line add is we use this, so we notice that actually there's a colon here for both if and else, and which is quite important when you specify the if um, statement. The simple one will be basically like I mean just one, and then I think I can add very simple one. So all these cases actually like I mean it evaluates true, so the first set gets executed and then the second set is ignored. You see like two things. One is I mean of course this column here, and then there is an indentation here in addition of these print statements same with else. The indentation is quite important in Python. The indentation gives it the framework of what is the it's almost similar to a function call or like a function statement. The elif statement is actually it's very similar to else if in C or ELSIF in Chickle or even Perl. So here is a simple one where x equal to 1, then print 1, x equal to 2, else if or elif print 2, and then else print main. So if it is 2, then this particular thing will catch and then will print 2. So now let's go into the more the next level. So one thing on the elif is basically like you can have as many elifs as possible in this one, that is if first one colon then blah 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 and then elif second condition blah 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 colons, and then there may be several elifs before you can actually go to a else. So this is one thing that you may want to just see basically. Now Python also supports loops which we will talk about in the next section. There are while loop and for loop are supported, so we will talk about that. Now let's look at functions. Again in function we will talk about how do we define function. We already saw like some of the basics of functions, and then we also see how to do the return values, local variables, which we will cover once again the scope, and then some built-in functions, some functions of functions, and then how do we pass lists, dictionaries and keywords and into the function. So let's begin. The functions basically you define them in a file above the point where they are used. So you need to define it before you are using. The main reason is Python is interpretive language, so you need to know what it is before you can use it. And the body of a function should be intended consistently. So 4 spaces is typical in Python, so everything like in 4 we increment. So here we declare a function called square, and you can see basically like it's a definition, the function name followed by colon, and then we leave 4 spaces and then we basically define the function. So the usage will be, you can say like print square of 3 is, and then call the square function square 3, and then the output will be like square of 3 is 9. So couple of things, one is the def statement, which is essentially the first statement that is specified for a function. How do we define it? The def statement is executed. Basically it's not like parsed and thrown away. Basically it is executed, and that is why we need to define the functions before we can use them. And what happens is when the def gets executed, the def creates an object and assigns a name to reference it. The function could be assigned to another name. The function names can be stored in a list, etc. And we can put a def statement inside an if statement, and it can be like nested and basically like it's all okay. Arguments to a function are optional. If you have multiple arguments, you basically separate with commas. And if there is no return statement, then none is returned. The return values can be simple types or tuples, or basically 2-element array, just like the A comma B. And when a function returns the values, they may be ignored by the caller itself. One thing to note is the functions themselves are typeless. That means that we can call with arguments of any type, as long as the operations in the function can be applied to those arguments. And this is considered as a good thing, because now you don't have that dependency of the type of the argument anymore. Now this is something that we saw earlier. As I mentioned, variables declared in a function do not exist outside the function. So here is one example. Def square n, which is m is defined as n squared, and then return m. So if you say like square of 3, and then if you ask it to print square 3, and then you print m, Python will generate this error. So this is the opposite of what we saw in the first slide regarding the scope, because this m doesn't live outside of this function, which is these two statements. So it cannot actually live outside. We can capture the value of square 3 because it is returning the m. We can capture this as basically another variable called m itself. M equals square 3, and then it will be there. But this way, even though this will work, this doesn't work, so the file comes up with an error. The variables assigned within a function are local to that function call that we already saw, and then variables assigned to the top of the module are global to that module. There is only global within a module. So this is the use of global to represent the global value of the variable. So within a function, Python will try to match a variable name to one assigned locally within the function. If it fails, it will try within the enclosing function that defining statements, that is def if appropriate. If that also fails, then it will try to resolve the name in the global scope. If none of these match, then Python will look through the list of built-in names. So what are the built-in names that we will see involved? So on the scope, essentially, like another example here, A is 5, C is A plus B, and then return C. Then if you say func4, what does it return? And when we say print C, basically then it does not return anything. But it basically like prints 4 plus 5 is 9. So within the function we can still make it print, but once it is outside the function it becomes non-defined. So here is another example. A is equal to 5, and then we say like global C, and then C is A plus B, then return 5. So outside, when we say func4, it's actually now gives the result. And then if you say like print C, then now it's also defined, and it's defined to be 9. So this global variable actually helps in straightening out some of the deficiencies earlier. And notice that actually the evaluation takes place within the function, like does this addition and then assigns that to C. So unlike other programming languages like Perl, Python in Python everything is by reference. But please also note that there are mutable objects that are not changeable. So changes to immutable objects within a function only change what the object name points to, and it does not affect the value itself. And it also does not affect who calls that program. So the immutable objects like integers, strings, tuples, Python acts like a C, acts like C is passed by value. And for mutable objects, that is example is lists, Python acts like a C is passed by pointer. In place changes to the mutable objects can affect some earlier changes. So here are some examples. One is passed by reference. Here we define the function f1 x and comprises of x and y, and then we just print out 1 plus 1 is plus 2 plus 1 and the other one is plus 2, and then we just print out all the values. Now we take the next function x f2, we declare x equal to x times 1 and y0 is y0 times 2. So this is presumably like this is an array function. So now when we ask it to print out, basically it prints out 0 and then 2 2. Now we continue, basically we make it a equal to 0, b is 1 and 2. Again it needs to be an array for it to be used inside. Then f1 ab, that's what we are going to call, so that returns this value, and then actually this is 1 and then it's 21 or 2, and then we say basically like print ab and then it prints this, and then we apply the second function and print ab, it prints 0 and 2 and 2. So here we are just passing the reference into the function and then getting back the reference. And multiple values can be returned by a Python program, but usually they happen with packaging it into a tuple or a array. So here is a small package, basically 1 2 3 x times 1 x times 2 x times 3, and then if you print the 1 2 3 program with the value of 3, then you get the result as 3 6 9, because now you can return 3 values instead of 1 or 2. Now Python has a rich set of built-in functions. For example, math.py, in your installation you should be able to see there are several functions available, and they are all pretty much free. One is the point POW. So when we say like POW 2 3, that's basically like stands for power. and basically it computes the so if you say like this is a and b, this computes a to the power of b, and ABS stands for absolute, so this is minus 14 and that becomes 14. And then these are some of the nifty commands to find the maximum amongst these numbers, and then here it outputs as 3, it's the highest integer there. So these are some of the fun things to do with Python. So I hope you'll enjoy this. Now function of a function essentially. So here is even is a function basically which has x and f, and then we do a test basically if x is the same as f of minus x, then we return true, else we return false. And how do we determine this? It's because we now do a square basically. So we are defining another function called square n, and then which returns basically just the multiplication. And then we also define another one called cube, and then that returns and n times n. So now we say okay, print even to square, and then print is even to cube. So the output of these two are, the first one is a true and then the second one is a false, because you can see basically. So first thing to note is this is one function, and basically this is the top level function, and here essentially all we are saying is basically that if x is same as f minus x, then return true else false. Now when we talk about in square, basically we only return an n or n times n, and the same thing here. So now if you look at this one, actually it is a function of a function because you are calling the easy one with an argument 2, and then basically also we are calling the square. So for square you need only one number. So basically what happens is it knows that okay, it's a square and it passes this number into that square, computes the answer, and 2 becomes x, square becomes f, and then it's again the easy when is evaluated with these numbers, and then it comes up with this answer. So now some default arguments like in C and Java, we can define a function to supply the default value for an argument if one is not specified. So these are useful for printing out the error messages and things like that. So here we have defined a function called print error, and it gets line number and some message, and the message is error already, like it is predefined here. So and then we just print basically the error message, error at line number so and so, and then that's the line number. So when we say like print error 42, it just prints basically error at line number 2. So these are like predefined values that you can supply into the function, and essentially like that's what we get. So now let's talk about the function without any return value. In general, all the functions in Python return something. If the return value is not given, then by default Python returns none. So this is a principal difference between Python and Tcl. As you know, tickle actually returns last evaluated expression. So when you are writing like Python code, beware of assigning a variable to the result of a function which returns none. For example, here the list append function changes the list, but it does not return a value. So when we say basically like okay A012 and then we say basically A dot append 3 and then that is assigned to B, and if you say print B, it prints none. Even though this is executed in correctly and basically like the new list will be like 0, 1, 2, 3, but it only prints none. So you may assume that okay now that this is correct, it should get a value of true, but the actual value that you get is none. So this is basically like what I wanted to cover during this lecture. So we talked about several things. I hope you remember. We talked about the scope of the variables. We talked about um, the conditionals. Essentially, that's what we started with. Basically, true and false booleans. Then we went into like how to compare logical operators, comparison and the logical operators, and then we also talked about if, elif, and else statements. Then we continued our look into functions. How do we define function? How do we actually execute the function? And then what are the other things associated with it? One of which was the scope, and we went into more depth rather than just mentioned it in passing last time. And then we went into like these values, the various scope examples. And then we talked about how the reference works in Python, and then we saw some examples. How do we use multiple values from functions, etc. Okay, so thank you once again, and we will see you in the next lecture. Thanks. Hey Santosh.